Okay, so it's late in the evening. Everybody's tired after this long presentation about Hadoop. So I'll be quick because well, I don't have really much to read from slides. I only have pictures mostly, so it won't be so intense. And if you have any questions, you can ask as we go anytime you wish. So a bit about me. I am a Java developer at Ignite, the same company from which was Alex, who presented the Blender API last time. And recently I've started researching this interesting topic about how to apply HTML in mobile gaming. And today I basically will tell you about my findings and show you my kind of proof of concept game for this topic. And the plan is really simple. For the talk, I'll tell you why you might consider HTML to be an option for mobile gaming, and what are the options, what technology stacks can I use to build a mobile game in HTML. And finally, I'll show you how I did it, what approaches I used, and basically I'll show you some code. So why? Why you might consider like HTML a better approach than native today? Well, obviously it's cross-platform. You don't have to write the same code, the same logic in different code over and over again. So you write it in one language. About 80 to 90% of your code will be the same for each platform, and then you have to kind of only adjust to those cross-browser issues that you get. So you still get some inconsistency between platforms, but at least it's easier to maintain one code base with small differences than 4 different code bases. Well, development cycle is really simple, really short. If you are building a standalone game, which is most of the case for your first or second or third game, then you only need basically a text editor and a browser. That's it. You edit your code, you refresh the browser, and you get changes immediately. You can immediately see your outcome, and you can apply all those debugging tools like Inspector or Firebug that you're already familiar with, and you don't need any large emulators that take a lot of time to load and take a lot of memory, and they need to restart your application on them, and it just takes time. Here it's really simple. It's a browser and a text editor. And if you're building a game with a backend, you're still kind of comfortable with it, because you're basically building a website. So all the technologies that you're already familiar with in web development are really easy to reuse here. You need a Java, a PHP, or a .NET backend, and your client side is basically a web page. So it's really simple to kind of map your skills as a web developer to this new field where you have game development. And well, actually, most of us are web developers. And it's especially true in Estonia, where most of us work in companies that offer services for customers that need some kind of new web system. And it's also easier to find a web developer.
Show my German friend slides. Do you see them, Robert? Do you?
Yeah, thanks.
Okay, cool.
Okay, so it's easy to find a web developer. Then it's easier to find them as, for example, an Objective-C guy. So there are lots of them, and you kind of have no problems with building a team if you want to build a game. And this eventually it all adds to less costs. Either less costs in your time-wise, or money-wise, or effort-wise. So this is actually the big benefit of this approach. You save your time or your money. But you know, it's not so simple, as we know. Like, then the whole world could then build web apps. But web apps are still worse than native today. And those common kind of problems that get with web applications, and they kind of translate to games also, because games are even more CPU-intensive applications. Is the problems that arise with them are that they are not so smooth, they are not so fast, and they are not so native as the native application. So regarding this last point, I mean it's you don't have access to all the hardware. The integration with the system is still kind of not that perfect as you get with native apps. This hardware part is actually being already addressed. It's this new kind of API is called Device API, which is currently as a working draft in W3C, but hopefully it will be done soon, and we'll see browsers already having access to all the hardware features that we need in rich web applications. For example, camera access, notification access, and so on. And well, regarding this slowness of the application, it is true that for current or older devices, it is still a big issue. But on newer devices, this gap between web app and native app is shrinking already. And on newer devices, you see that the performance is really not so much of an issue. Okay, that was why you might consider web application to be, like web technologies to be your technology stack for making mobile games. But actually, how you do it, how you create a mobile game in HTML. There are basically two approaches. First of them is a pretty straightforward way for that typical web programmer to start. Is you build a game as you build a web page. You basically have a bunch of divs that are given position absolute, and you're kind of making and putting pictures to them and animating them. So it's a really straightforward way. You use your favorite DOM manipulation frameworks like jQuery, for example, and you have some divs that you move around and make this user experience think that user thinks that it's really an animated game. And slightly different approach to this DOM approach is to use drawing APIs. You basically have three options, either SVG, Canvas, or WebGL. Canvas seems to be the most promoted way currently, most promoted approach by major players like Google, for example, and lots of kind of buzz is going around this approach. Lots of libraries are emerging, and currently it seems to be the pretty the most like kind of tried out way to build games. And WebGL, it's actually might be the future. It has some support for 3D. It's hardware accelerated, but it's still not so well supported by mobile browsers. So at least at this point, it's not really ready for mobile. And the third approach is to use them both. You might have a menu built out of HTML, and you might have a game that is built in Canvas. So, about how you build a DOM game. You take either some DOM manipulation framework, for example jQuery, that you're already kind of familiar with if you're a web developer, You might use MVC framework, like a Backbone, for example, that if you feel that this is better than the pure DOM manipulation framework. For storage, you will probably use local storage. It is well supported on even mobile browsers, and it's basically a kind of an endless cookie. So to say, you put stuff there and stays there until user cleans it. You might also use WebSQL, which is kind of more advanced way to store data in browser, but it's really complex, I think, for like typical cases. And it's kind of half deprecated already, so probably local storage is better. You apply some CSS magic, like you do with your website. In CSS3, there are lots of new goodies that you can use. For example, animations and transitions. They are fast and they are declarative. So it's really easy to get started and really easy to write them. And of course, media queries, they help you here also a lot to adjust your game to different screen sizes. Well, you build a game and ultimately you want to package it into native and put it to some store to sell for free or for money. There you would probably use PhoneGap, which is a packaging tool that also offers kind of JavaScript bridge to gain access to camera, notifications, and all those hardware features that you want to use. And that's it basically. You build a game, you kind of plug the technologies, and you package it, and you release. Things to look out here are is of course performance. On slower or older devices, it's still an issue for this approach because well, HTML is like an extra layer, so it takes resources. Cross-browser issues. They are not really so much of an issue because if you're using PhoneGap, then your packaging on Android you would use the default browser, which is WebKit, and in iOS you would use Safari, which is also WebKit. And if you want to support Windows Phone, then you have to support IE. So really, WebKit and IE is all you need to support. That was the DOM approach. Now let's see how the Canvas approach differs. There are also kind of two set of libraries that you can use. First of them are general purpose libraries like Kinetic.js and Easel.js. They are kind of, they build this object model on top of this dummy canvas, which is just a thing, just like an API where you say like, draw me a line from coordinate 510 to -60. And instead of that, you kind of have those objects that you can tell, like, draw yourself. Objects know how to draw themselves, and they can be arranged into containers that know how to draw their children and so on. It's kind of very similar to how Flash works, and Flash was very successful with animation, so this approach kind of was taken over by those libraries. And they are free. But they are don't really help you in game development. They are kind of fit for anything you wish, any kind of animations. A different approach can be with kind of game-oriented frameworks. Two of the most known are Impact.js and Construct2. They kind of offer the full solution for game development. They offer SDKs and IDEs that you can use to create games with like literally no coding at all, and they are paid tools. So I haven't used them. I don't know if they are really that good, but I am very well comfortable with those general purpose frameworks. Storage, again, you use probably local storage, and you might package it with PhoneGap, which is like straightforward, but it's will really be ridiculously slow on mobile. It won't actually work pretty, the performance issues are really bad. Max 10 frames per second or something. Maybe on newer devices is better, but still, performance is really bad on mobile for Canvas. That's where different kind of set of technologies, different approach came in. It was first pioneered by AppMobi, who created Direct Canvas. This kind of technology is called accelerated canvases, and what they do, they basically implement Canvas API on top of, directly on top of drivers. Maybe not directly, but closer to drivers than the browser does. So you remove this whole browser overhead that you don't need, and you leave only the canvas part. And this way you can kind of write code that is executable both in the browser and in this emulated environment. So it was environment for the mobile and browser for desktop for programming. And I've tried those accelerated canvases. AppMobi's approach it works, but you have to write some ugly boilerplate that is not really compatible with the browser. So you need to work inside their own SDK that they provide, and it's really not so kind of convenient. You would probably prefer working in your browser that you already are familiar with this Fireblock and stuff like that. That's where Uday came in with their kind of different approach to accelerated canvas. They created Cocoon.js, which offers you 100% compatibility with the browser. So you write the code you usually write for the canvas. You have to keep in mind some of the rules that you cannot create elements besides those that you actually need for the game. For example, only canvas, audio, and images. You can't create anything more. And if you stick to those rules, you're okay. You will make your code will work both in the browser and in the mobile on every platform that they support. Currently, they support only iOS and Android. So I tried this approach, and it really worked. There were some issues you have to keep in mind. What you write, you don't have the luxury to create manipulate the DOM so much. You only have to write only canvas code. And still, with this, performance is okay. It's not like native performance, but you still get playable games with close to 30 frames per second on slower devices, and on newer it's really fast. But still, if you want to support those slower devices, you have to keep in mind that you need to do a lot of performance tuning to get those frames per second higher. Yeah, as you don't have browser usage here because Canvas doesn't have really any complex logic. So, and generally, if you stick to those rules, your code will work in both the desktop and the mobile. The third approach, which I mentioned, can be a mix of those. But and it is quite tempting to choose it because we have the power of HTML to define the structure elements that you like. It's hard to create the code. For example, menus that can surround your game, and you have this canvas that is really suitable for animations. But I've tried this approach and it failed for me because you kind of have to support two types of code. Support both the DOM manipulation code and the canvas code, and you have to include the jQuery libraries, for example, and Kinetic.js libraries, and your code kind of piles up into a big mess. And of course, you cannot use accelerated canvases. And if you package this canvas with both with DOM into PhoneGap, it will eventually still be slow. So currently, this approach is not very well suited for mobile games. Okay, so still a question there. That was it for the slides. And actually, I will now show you some of the games, or one game actually, different versions of it that I tried to build over time, and that actually work in both iOS and Android. This is the first version where I used DOM plus Canvas. I will try now to reload it. It's kind of this is like the initial stage. Don't look so much at the animations. It's like.
What does it mean?
It means something like solve or solution in Chinese or something. So you have this. It's like half done, and I kind of dropped this idea, so it's kind of messy a bit. But it's here to show the idea. So this is currently DOM. Like you can like make swipes here, and like you kind of go there, so it kind of shows this bumping effect. It's all CSS3 animations. So and if you kind of swipe to continue means like you go there, and you can go there. It's all like CSS3. So they are pretty fast, those animations, and they are easy to write. So still like you have those bumpings here. Continue, swipe to begin, and you begin. This is already Canvas. So like you kind of see this integration of DOM plus Canvas is really kind of smooth, so you don't notice where you go from DOM to Canvas. And you kind of can click stuff here around, and so yeah, everything twice here, and you can go back, for example. Yeah. And if you want a menu, you can swipe. Yeah, this is also CSS3 animations, and yeah, also kind of on top of CSS3 animations. You can select a level, and the next kind of level selection menu pops out. Select this, it goes fades in, fades out. You have something maybe not new, but anyway, it's half one. And for and how local storage works, it uses local storage. Damn it! I need to now config this to not to go from 0. So now I'm flushing the memory, so each time it goes from 0. Okay, so we got, and if you are reload now, so you can see this fading effect also. So it reloaded and the state is saved. I can click something here, and I reload, and it's still the same. Yeah, and you can see that's really slow because I tried some ideas here. If you can see, it has a slow grayscaling effect. It kind of shows you the power of Canvas. You can manipulate each pixel. You can make filters, make blurring filters, and but it's really slow if you kind of have animation on top of those pixel manipulations. So yeah, and if I'll show you some code here. Let's see, for example, I have those tips here that represent screens. So this is kind of the power of DOM approach. You kind of have the luxury to create your structure in the DOM elements, and you need to apply some CSS to make them work. But it's really really easy to make menus, for example. And it's really cool to make games in Canvas. I mean, you have this synthesis of those different approaches, but from my experience, this failed because of the mentioned problems. I can show you a bit those CSS animations. So they are really declarative. You have selector here, and you have how much time it takes, and what is the easing function. You see that for each browser you need to have a prefix, because currently it's still not so well supported. It's not standardized by browsers, so you need to have write the code triple time.
Why don't you use less?
You can use, but currently I just wanted to stick to no libraries at all. And it's not so hard actually to write it. I don't want to compile the stuff again to make CSS and stuff. And actually I didn't use jQuery here also. So one of the approaches promoted by a lot of mobile game developers that develop games in HTML, that you actually don't need an external library, because you need to save those precious CPU ticks and if you write your own stuff, you have two bonuses. You get into the details of this library that you want to use, and you understand things better, and you save those precious memory size of your application, and you don't have this overhead that jQuery, for example, does for all the browsers, because you don't need to support all the browsers here.
You can generate CSS during development time.
Yeah, I know. There are tools for that, but at that time when I wrote it, I didn't know about it, and I didn't want to know. I just wanted to experiment. So, for example, these sliding effects are done translate by 100%, then bump 5% across the edge, and then go back. Yeah. But this example is not actually so interesting because it's a failed example. The most interesting is the one that is actually working, and this is a pure canvas approach. Here you can see the similarity, but you can see it's really fast, a lot faster, and it has sounds also. It has menus and stuff. And this is the pure canvas approach. Zero HTML, just canvas code. And it's highly optimized, so it's fast. And just to show you this code, the file is really simple, the HTML file. It's only script text, so no HTML at all. Because you don't need to define script tags in your head actually, because browser knows that it's script tag. I mean, you don't need the HTML tags, so only script tag. And those tags create the game. So there are you have lots of files here that address different things, and you have I have the common functionality here that I can reuse in later projects, for example, lines and points and geometry stuff, and persistent objects and environment and some string, additional functions to strings and functions. And I have the game logic here. So really simple approach. And I can see I use only Kinetic.js here as external library. So I tried also to minimize my dependency on external libraries. And here are all the files. And I also built a tool that processes the file, builds one big JavaScript, sends it to Google Closure compiler that compiles the code into a minified JS, returns the Mihhail.js to me, and I write it to one file. So eventually, in my target folder, I have only one index file and resources. So this, I don't want to open it. Eclipse will crash because it's one long line of million characters. I need a special extra. I can open with some other editor that doesn't. It's friendlier to big files with one line.
Less command line.
No, I don't want to use. I would probably use some. Yeah, it's this file.
What's the size of this file?
Not actually big. It's like 100 kilobytes. The most of the size is taken by images and music. So I have these images here and levels and audio stuff, different formats for the different browsers, different screen size of different pictures. Yeah, that's I think enough for the desktop, and I'll try to show it that it works on mobile also. If it's still alive. So okay, for load. Take my Android also. Okay, okay, Android. So if it's not so, like it's really small screen, but I mean, yeah, it's still the same game with 0 code notifications. You can see the frame per second here. It's like around 30, and on the animations, not so much, but it's really old Android. And if I can load this iPad here. Yeah, it's loaded. So, yeah, same game on iPad. Yeah, it's there. So one game, one code base, desktop, iOS, and Android. And one more thing to mention about my setup here. I use Dropbox as my workspace because this emulator on those devices, it can fetch code from external URL, so it's really easy to test. I mean, I make changes in my Eclipse, I reload it here, and I immediately can test it on device. So really simple. And I can work from different computer also. I use the public folder. I guess nobody will look at it so much. But yeah, it's not it's this code is not like a secret. Maybe I'll open source it someday. Yeah. And I think that's all I have to say. So, yeah, you can find more interesting stuff if you scan this QR code if you can. It's linked to the blog post that is where you get more data, more info about this topic. It's actually, this presentation is partially based on this blog post. Yeah, you can also always write me. And this on ignite.ee, we have also blog where this blog post is posted, and you can also read from there. So, yeah, that's I think all from me. If you have any questions.
A question: how do you test these canvas games? Which tools are available for automation, for example?
Any JavaScript JUnit framework that you want. I mean, like, if you want to test visually, you have to play it. if you want to test the logic, it's still JUnit.
Well, for example, if it will be HTML, you can use Selenium for this, but if it's a canvas, you cannot.
You can also use well, you can use kind of not it doesn't have elements, of course, but maybe you can program some clicks into some points of the screen, but it's literally lame. You cannot select anything from canvas actually. Yeah, each approach has its positive and negative sides.
Okay, any more questions?
You said you have optimized
Basically, you need to optimize your images because images take. I mean, the bigger the image, the more time it will take to render it. So what I did, for example, first of all, I learned a bit of Photoshop. I kind of know how to export images that take less space. I kind of process them a bit, remove some of the data from them, I kind of optimize it to be like really compressed. And I have two sets of images. I have images for smaller screens and for bigger screens. I kind of here I tackle two issues. First of them is when you have only big images, when they scale down, you will have it won't look good. Like it's anti-aliasing is not you don't have it's not like kind of you don't have you're not sure that it will be anti-aliased. And if you scale it really a big image into small, you will have like a bad quality image. So I have kind of precisely calculated what images I need for small screens like mobile phones, and I use one set of images for them. I render them quickly because the image size is smaller and I don't have those rendering problems with resizing big images. And for bigger screens, I have bigger images that are well for example, for tablets, and there you have bigger screens, so you also kind of don't have much to resize. So that's
SVG for this stuff. Maybe.
Yeah, but Canvas is pixel based.
The whole game in SVG.
Yeah, you can use SVG for gaming also.
Have you tried it here, no?
No, I used Canvas only. I know, well, SVG is, well, I mean, for gaming, vector graphics, I think, is not the best for 2D gaming, because you kind of have to manipulate, you kind of have to, in SVG, you need to kind of define mathematical paths and stuff like that. And for games, you kind of want to work with pixels, basically. It's easier to work with pixels. SVG vector graphics are, I think, better for charts. That if you want to render charts, for example, you can zoom in and see the details, and it won't lose the quality. Yeah. But maybe I'm wrong. I'm not a professional game developer. That's my experience.
My question is about this WebGL 3D games in a browser. So the game in a browsers are not so modern. What do you think? In what time they will be like as modern as native games like shooters or what?
You mean 3D shooters in mobile?
No, I mean like on PC native games. When will they be in the browser that's so good, like with these 3D objects and all that?
Oh.
In what time?
It's hard to say actually, because part of the problem is that those companies want to keep their code like secret, and they kind of prefer to use compiled languages also.
So no, but I mean this hardware acceleration with WebGL. This WebGL is still like young, so it doesn't have.
Well, I hope it will be like maybe in a year or two, it will be already kind of well supported. It actually is already supported by desktop browsers. It's I think it's by default it's deactivated in the browser, so we have to activate it to be available. I heard somewhere that Google Maps is based on WebGL. I'm not sure, but yeah, they are apparently. So it's already used, and if Google Maps are pretty fast, then I think the technology is kind of already catching up. But I don't think that shooters will be like in web browsers, because like there are lots of other issues like code privacy and they want to have a package. And
no, it's that I think it is relatively. They become relatively simple to do 3D game with these new technologies.
Yes, I think so. But technologies are all about simplicity and availability. I mean, you have like really like a low learning curve. I mean, it's really easy to get into it without learning big SDKs and stuff like that.
How much did it take to write the game?
From day one, when I just started researching what is HTML5 canvas, till the ready game, it took a bit like 6-7 months. But
Of pure work?
no, I didn't work like that. I mean, like free time, like more like whenever I have time, like, and it's not occupied by other more prioritized tasks, then I do this. So yeah. And
have you tried multiplayer games with Node.js on backend?
With
Node.js server on the backend.
Node.js. No, I haven't tried. I think I will try soon WebSockets. Yeah, I think yeah. Well, it doesn't matter if you have Node.js or some other backend. I mean, JavaScript in the backend doesn't really matter. It matters this like integration with how you integrate. For example, WebSockets are promising. You kind of can build already like real-time kind of web-based games, and they are already kind of supported in the last Apache, I think, and they are coming soon to Spring, so it's looking promising.
Okay. So I guess this was the last one. Thanks.
One more thing.
No?
Our website is supported by mobile.
Not sure, haven't checked, but I think they are. At least this Canvas emulator already has support for them, and I think it will be soon if it's not already.
The WebSocket is browser thing, not the...
It has to have server support also.
Okay, then that's all. You can ask him later also questions.